Lesson 5-3, solving quadratic equations by factoring. So instead of using a graph, we're going to find the roots or the zeros by factoring. So these are kind of the steps that you're going to follow. First of all, you have to make sure that the equation is set equal to 0. And sometimes it helps too if you've got it in standard form, the ax squared plus bx plus c equals 0. Then you're going to factor the left side of your equation, then set each factor equal to 0, and then you'll find your solutions. And typically for quadratic equations, we're going to find two solutions. All right, so here's the first example. The equation is a squared plus 5a minus 14 equals 0. Now, because I have a trinomial here, and the value of a is 1, I'm talking about the coefficient in front of a squared here, it's pretty easy to set up two binomial factors. Okay, so what I'm really thinking here is the opposite of FOIL. In other words, what are the two binomials that would FOIL or multiply together to give me an a squared plus a 5a minus a 14? So the first two terms multiply to give me a squared, and that's probably a times a. The last two numbers in my binomials multiply to give me negative 14, and I know that when I multiply the outside terms and the inside terms, they should add up to 5. So I'm looking for two numbers that multiply to negative 14 and add up to 5. So if I kind of make a table off to the side here, what are some factors of negative 14? Well, I could do negative 2 and 7. I could do negative 7 and 2, 14 and 1, vice versa. But I think I found the pair that works here. I want the ones that add up to 5, and that would be negative 2 and 7. So that tells me that my two factors are a minus 2 and a plus 7. Once you have it factored, you're going to set each factor equal to 0. So we've got two factors here. The first one is a minus 2, set it equal to 0. The second one is a plus 7, set it equal to 0. And now you solve these little mini equations and you get your two solutions. So the solutions here would be a equals 2, because I'm going to add 2 on each side. And over here, I'm going to subtract 7 on each side. 0 minus 7 is negative 7. So my two solutions are positive 2 and negative 7. Now I'm just going to show you on this first one, if you wanted to check your answer, you can check it by plugging these into the original equation. And I want to make sure that I get 0. Okay, so we're just going to check this one here. I'm going to check that 2 works in the original equation. Is 2 squared plus 5 times 2 minus 14 equal to 0? Well, 2 squared is 4. 5 times 2 is 10. That's 14 minus 14 gives me 0. Yes, 2 works. Now let's check negative 7. Negative 7 squared plus 5 times negative 7 minus 14, will it give me 0? Well, negative 7 squared is negative 7 times negative 7. That's 49. 5 times negative 7 is minus 35. And then if I subtract 14, I'm going to end up with 0. Yes, negative 7 works as well. Okay, so these are the two solutions to the equation. Two values work here, 2 and negative 7. Let's try this one. I want to solve for x. X squared equals 2x plus 24. Before we begin, I need to make sure that the equation is set equal to 0. And I'm also going to put it in standard form here. So I'm going to subtract 2x on each side. And I'm also going to subtract 24 on each side. So my new equation, here's the three terms here. X squared minus 2x minus 24 equals 0. On the right side, I've canceled these out, and so I get 0. Okay, now again, I've got a trinomial. It's now in standard form. Typically, a trinomial is going to factor into two binomials. So let's set them up. I'm looking for two factors here that will FOIL into this trinomial. So again, I know that the first two terms multiply to give me x squared. That's got to be x times x. The last two numbers multiply to negative 24, and they should add up to negative 2. So again, if you're kind of stuck with these factors here, make yourself a table. What are some things that multiply to give me negative 24? Well, I've got 2 and 12. One's negative, one's positive. I've got 3 and 8. One's negative, one's positive. I've got 4 and 6, negative 4 and 6, or negative 6 and 4. And you look at your possibilities. Do I have any that add up to negative 2? That would give me a negative 2x in the middle term here. Well, negative 6 plus 4 is negative 2, and so these are the two numbers that I want to use. Negative 6 times positive 4 will give me negative 24, and when you add them up, you're going to get negative 2x. I'll have a negative 6x, positive 4x. Okay, so we've got my two factors. Now we want to find the solution, so set each factor equal to 0. X minus 6 equals 0, x plus 4 equals 0. What are the two solutions? Well, in this first case, I'm going to end up with positive 6. And in the second case, I'm going to subtract 4. 0 minus 4 gives me negative 4. So positive 6 and negative 4 are the two solutions. Now, what you're going to notice about your solutions is that they're exactly the opposite of the numbers that you've plugged in. And that makes sense because if you set these equations equal to 0 and undo the operations, you're going to end up with the opposite number here. So because negative 6 and 4 were the numbers that worked in my two factors here, the solutions are going to be positive 6 and negative 4. That comes in handy for the next example. Okay, so in this example, we want to write an equation in standard form with the given roots. And roots is just a fancy word for the solutions. Okay, so in this case here, they're telling us that the two solutions are negative 4 and 6. So pick any variable that you want to use. I'm going to use x. We know that the two solutions are negative 4 and 6. Now, what does that tell us about the factors? It's actually exactly the one that we just did. If x equals negative 4 is a solution, I know that the factor had to have been x plus 4, the opposite of my solution. And I know that the other factor had to have been x minus 6. These are the two factors that would give you these solutions. So x plus 4, x minus 6. Now, we want a quadratic equation. So I'm going to set this equal to 0, and I need to FOIL now to get back to the original equation. So x times x is x squared. X times negative 6 is minus 6x. 4 times x is positive 4x. And 4 times negative 6 is negative 24. Okay, so if negative 4 and 6 are the two solutions here, what was the equation? Well, it had to have been x squared minus 2x minus 24 equals 0. So you're kind of working backwards with these examples. All right, let me show you another one. In this example, we've got the two solutions, 1/2 and 1/4. Okay, so I'm going to use the letter y this time. If I write our two solutions, y equals 1/2 and y equals 1/4. Can we write the two factors at work here? Well, yeah, you certainly could say y minus 1/2, y minus 1/4. That'd be fine. The other thing you could do, though, really, is kind of work your way backwards and figure out what the two factors were when they were set equal to 0. For example, I could take this equation here and multiply both sides by 2. So I'm going to have 2y equals 1. 1/2 times 2 is 1. Now, if I subtract 1 on each side, I kind of get back to what the factor is, really. I mean, at some point in solving this and getting my solution of 1/2, I'm guessing that the factor was 2y minus 1. So if you kind of work your way backwards and try to set your equations equal to 0 again, you can figure out exactly what that factor was. Let's do the same thing with y equals 1/4. If I multiply both sides by 4 to cancel out the fraction, I get 4y equals 1. If I subtract 1 on each side, kind of getting myself set up equal to 0 here, I get 4y minus 1 equals 0. This has to be my other factor, 4y minus 1. And so this is kind of a way of getting around working with those fractions. Would it have worked from the beginning to say that your two factors are y minus 1/2 and y minus 1/4? That would have worked, but when you FOIL, you're going to end up dealing with a lot of fractions. So instead of doing that, here we can get some easier factors to work with. Now we want the equation set equal to 0, so now all I need to do is multiply everything out. So 2y times 4y is 8y squared. 2y times negative 1 is negative 2y. Negative 1 times 4y is negative 4y. And then negative 1 times negative 1 is positive 1. So, combining like terms, putting the y's together, the original equation must have been 8y squared minus 6y plus 1 equals 0. There's my quadratic equation in standard form. All right, so last slide, I've got a couple for you to try on your own here. The first one I want you to solve by factoring. So write two factors here, two binomial factors, set them equal to 0 and get your solutions. And then number 2, what would the quadratic equation be if the solutions or the roots are negative 2 and positive 1? We'll check those tomorrow when you get to class.